Now we can turn the rotation dial to start the system to rotate. You notice that I have my hand sort of ready to support in case it falls. Why do I think it may fall? Because we do not have the vacuum pump on yet. So, there is no vacuum holding this glass assembly except for the clip. So, to make sure that it does not fall down, I will have my hand right here just to support it in case. Now, let us concentrate on the glass stopcock assemblies that we have here. The first one here, you notice that it is in the horizontal position. I can bring it down and then it will be connected to this side arm which is open to atmosphere. You do not want to use this at all. Just leave it in the horizontal position so that it is closed and not open to atmosphere. Do not touch this. Now, the second one up here, if it is in this direction, that is facing up, that means it is open to atmosphere. If it is in the horizontal position, then the system is closed. If you can carefully see here, there is a hole. Now, that hole is right next to the glass wall. So, it is not connected to the atmosphere or to the pump or to the system here. So, the horizontal position means it is closed. If I turn this down, now it is the vacuum is connected to the system. So, again down position, the vacuum is connected to the system. Horizontal, it is closed. Up position, it is connected to atmosphere. So, just remember those, and before we turn the vacuum pump on, you want to make sure that it is open to atmosphere. So, up position and open to atmosphere. So, I am going to turn the pump on. And after turning the pump on, you want to carefully connect the system to the vacuum pump. That means we want to bring this down all the way, but slowly, not all at once. So, gently start to rotate and as the system gets connected to the vacuum pump, you will be able to hear a difference in the sound that the pump makes. Okay. I have not completely connected, it is partially connected. I want to increase the rotation speed. Now that there is vacuum holding on to the round bottom flask, I can take off my hand and connect the system now completely to the pump. That is making it completely parallel to this arm which is going downwards. So, the vacuum is now connected to the system into our round bottom flask. You can already see that the solvent is condensing and it is getting collected in this round bottom flask here, which is used to collect the solvent that is evaporated off from our solution. Now, if we have a solid inside this round bottom flask, if you know that your component is a solid, you have to be watching this extremely carefully, because sometimes the solid will bump into the bump guard. So, if you know that your component is a solid, then please have your hand ready here to reduce the pressure or the vacuum that is being connected to your flask as the volume in the flask gets reduced. So, I am watching here carefully now. As the volume goes down, I will start reducing the vacuum. In case you notice that there are bubbles inside the round bottom flask, then you can increase the rotation speed. But in general, the speed at which this is rotating is an optimum speed. It is a good speed to evaporate off the solvent. If we had to evaporate off the solvent in a regular fashion, that is not using the pump and the rotation method, it would have taken much longer, and then the setup also of course would have been complicated if you wanted to collect the solvent back, because you do not want the solvent to be evaporating off to atmosphere. So, you can see how efficient this whole system is to remove the solvent from the solution.